Okay, ladies and gentlemen, we have yet more log properties that we need to talk about. In this case, the properties are going to get a bit more involved. These properties are going to get a bit more involved. In this case, if I have log base b of something times something else, that's the same thing as saying log base b of x plus log base b of y. So what was a multiplication turns into an addition. So it's product sum. In this case, log base b of x divide by y. Well, if when you multiply, you change it to add, when you divide, you change it to subtract. Now, the reason this works, ladies and gentlemen, is because if I have x squared times x cubed, the answer is x to the fifth. What did we do with the exponents? When we had a multiplication, we added the exponents to get 5. Since remember, logarithmic functions are really just exponential functions, it would make sense that exponent rules apply. So if I have two things that are really exponents and they're really added, we're really multiplying. Now, if we have division, x cubed divided by x squared, well, what do we do here? We take 3 minus 2. So we change something from division to minus. And the same thing works in log rules. Now, if I have log base b of x raised to the p, if you will remember when we had log base b of x to the p, you'll remember that when we had the following, log base b of b to the x, the base b's canceled out, leaving x. That's just like if we were able to pull the x out in front of the log base b of b's. It's just that the log base b of b's happen to go away. In this case, the log base b of b's don't go away. They stay log base b of x. Now, earlier we had a problem we couldn't solve. Log base 2 of 14. Well, 2 doesn't go into 14. We can't even do it on our calculator because on our calculator, the only buttons that we have available to us are natural log and log base 10. So what we need to do is we need to find a way to find log base something else of 14. That's going to be the change of base property. Change of base property says log base b of x equals log base 10 of x divided by log base 10 of b. So, if I were to do this property back here, this example, I would say log base 10 of 14 divided by log base 10 of 2. The nice thing is it's not that challenging on a calculator. Go ahead and throw our calculator up here and we say log of 14. The only thing I need to be careful of is that I end that parenthesis divided by log of 2. And that comes up with 3.08. So that equals 3.80. Now, it kind of makes sense because 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. So it makes sense that 2 raised to the 3.8th power would be 14 because 14 is between 8 and 16. So it makes sense that it's going to be in that ballpark. That is your change of base. You take whatever the big number, log of the big number divided by log of the base. Now, those log properties also work for the natural log. So natural log of x times y is natural log of x plus natural log of y. Natural log of x over y is natural log of x minus natural log of y. Natural log of x raised to the p equals p natural log x. And the change of base property applies for natural logs. What I want you to accomplish on this one is I want you to do these problems right here. Do example 1, 2, 3, and 4. See what you can come up with. Be ready to turn them in.